So to recap, we want to write a dbus library, or we are writing a dbus library, because at this point in time, we want to be able to show a taskbar in our window manager, like this guy down here. We want to expose the window list over dbus because that seems like a reasonable API to do that. It doesn't seem like it should go over Wayland. Wayland's really more about like displaying the window, and in my gut, I feel like, you know, if other applications want to like discover and query the window list in our window manager, dbus seems like an okay place for them to do that. Our dbus library was pretty clunky when we implemented it before. We did a quick check last stream about how we would do a dbus service. We kind of like understand how to do that. We understand where we want to go. And so we've been doing some refactoring to get there. During this refactoring, we've ended up at the point where there was only one place in the entire library that we do any allocations. And that is in generation, parsing of dbus types that come over the wire when there are arrays. So somebody says, hey, I want to call this function and you are going to give me back an array of data. So in this example that we've been working on, we have talking to Spotify, hey, could you get me all of the metadata for the current song that's playing? And he gives us back a metadata response where we generate code that says, hey, give us back an array of key value strings that map strings to like arbitrary runtime known data. So here we need to allocate because we are asking for a slice, right? And so like this data is kind of like packed into the dbus packet as like hand wavy. It's gonna be like some like dbus stuff, right? Dbus tracking data, like the length of the array. Then he's going to have like string length, string len, then string, right? Then he's going to say, he's going to have like variant tag. Maybe the variant is a string, so he's going to have like a new string len here, then string, right? And so if we're trying to like create this array of key values, we're kind of like allocating so that we can kind of take this string, put him here, this string, put him here, and do that back to back to back to back. And in reality, we don't really have to do that because all of the contiguous data that we actually need, like the string content, is already contiguous in the packet we're getting it from, right? And so the only reason we are allocating is to create a list of the pointers. And so I was thinking it should be possible to not do that, right? It should be possible to kind of lazily parse this stuff, specifically because in the dbus wire format, they give us like array len bytes. So every time you see an array, you can kind of just like skip parsing the whole array until later. And so the thought is that like, instead of doing this slice return, we could do like this, dbus array. And in dbus array, we just have like the raw data that's under there. And maybe this is like dbus array, you know, dbus array of like some type. And so then what we can do is we can like create an iterator that rips over the type and does like lazy parsing and gives us the data as we need it. And then with that, I think that there should be no allocations anywhere in the library. So that's the goal for today, is to try to figure out how to write that code. So the place to start probably is to convert the existing slice to a like dbus array, and then just kind of start figuring it out from there. So the way this works right now is we have like a definition for the dbus API of Spotify here. And in here, we parse this XML and we like generate this file out of it, right? So we see in this XML somewhere, like this is an org mprs media player 2 player. And so when we like look at that and we say, okay, we will generate an org mprs media player 2 player, right? And we like basically just construct all of the types that go with what they're asking for. So somewhere, for like get, was it get metadata? Metadata? Where does this come from? What is the function call we're calling? Get metadata. But get metadata is a property. So there's a property metadata right here that we create a function to get. He's got a type of an array of key values pairs where the key is string and value is a variant. That's what like this means. So somewhere in our code generator, we're like looking at this, we're parsing the type and generating a Zig type from it. Dbus to Zig type formatter here. And so what we do is we see like array start and we rip out, we just like drop the slice syntax in Zig. There is no array end in this signature. They kind of like have like an implicit end where it's like you have array and then like if it was like an array of ints, your type would just be AI, and you kind of have to know that that means that it's like the end of the thing. I don't really, so I think that we need to kind of figure out when, if we want to like create like a more complex type out of this, that's like instead of T, we want dbus array T like this. It means that we need to kind of like figure out where the end of an array is. Right now our type parsing is pretty fucking stupid. I think that we need to like a tag stack in here somewhere where we kind of like, because we might have like arrays of structs or something. So we kind of need to we need to like track how far down in this like stack of crap we are. So that we know when we pop the array to like close this brace. Something like that. We also have some like asserts in here that say like, right now we don't support like nested structs either. So we don't really know how to deal with that, but I think we can fix this. If we just have like tag is an enum of, array and struct, which looks very similar to something we did earlier today, actually. So this is a like maybe fix me, very similar to variant parsing code. Maybe here we have some tag stack buffer that surely we can't go more than like 10 of these deep. Surely. Buffer? Init buffer? Yeah, here we go. And so when we enter an array, I guess we do like append this like array. If we, what did we actually end up doing in the other thing? Hold on. Before we did like a little peek for some reason to do some like alignment stuff. That's not what we're doing here. Okay. So here we append array. Here we append struct. So here I guess we just go tag stack append bounded struct when we're in a struct. When we leave a struct, we probably want to pop, and we want to make sure that the thing we're popping is what we expect. So we're going to do a little assert here that the popped elem is struct. And then key values are the same as structures. They're like literally the same fucking thing. We're just serializing them slightly differently. So that's fine by me. And then it's like, okay. So I guess here we're gonna look at the last element. I'm not sure. I'm just trying to get like to preserve the existing behavior, right? So like if last elem is equal to struct, we write commas between elements, I guess. And then here we want to also check I guess if this is array, and we have gotten any type that isn't these, we're like ending a type. If we are ending a type, I guess we just pop that. And we have to close the array. Something like that. He doesn't like this for some reason because, because we are, we're returning out of memory, and that's not supported in this context. So that's fine. We hack it for now. We always hack it. Unreachable. We're outputting invalid code because here we're just fucking closing a bracket for something that we don't have. Oh, I think it's like this. Oh, let's fucking go. So this looks right now, right? So we have a dbus array of dbus key values, double bracket close. And now he's just like, we don't fucking have that. So how do we implement like this like dbus kv thing? If I remember correctly, we have like a metaprogramming marker that says this is a thing. So here we're like, this is a dbus array, and this is a dbus array wrapping type val. We're literally just gonna throw this as like a dbus array marker. And then in here for now, we're just gonna write this as a slice of val, right? I think that's the play for now. And then here, fuck pointer shit. We're checking for if has decal t for dbus array marker. We do this, and we say fuck pointers. Fuck pointers. We don't fuck with those, dude. We don't fuck with pointers. And this is I guess it's the type of inner hold on. This is like type of maybe like type info of like t inner. I don't really know how this works. Type info t. This is a struct. Fields, the first field type, I guess. No, because this is a pointer. So this is like inner t, and then this is like child is the type info of inner t. Ew. This is like a pointer child. It's like something like this. Okay. So now, when we look at this thing, we're looking for parse over parse inner. This guy doesn't know how to deal with this motherfucker. On implemented for field types for dbus variant. Why? It's right here, no? On implement. Oh, this is pointer. Oh. Wait, this is still here. Why is this still happening? Because we probably didn't handle all of them. Wait, I'm confused. Can we zig build f reference trace? Who is still using these slices, motherfuckers? This f reference trace is not helping. Oh, it's in our tests. Just fuck our tests. Just fuck unit tests. I've been saying that shit. There we go. Okay. So This is still parsing as expected, which is surprising. Wait, that's actually like super surprising? Because I didn't think I wrote the code. I didn't think I wrote the code to generate this dbus array on toConcrete, right? toConcrete, we're calling parse body inner. Like, am I fucking stupid? Like, this shouldn't be happening. Unsupported type. No. Wait, this is still fucked. Unsupported type. Oh, maybe it's like was happening to still work. Because it was a single field struct, and the single field struct had an array in it, so it might have just happened to be working still. Which is kind of funny. So I think what we actually want to do here is we want to take like this pointer stuff, and we just want to say like if there's like the marker in this thing, so like has decal of t of dbus array marker, then do the shit in pointer. And we need the child thing again. So there was like that inner t shit. We just kind of bring this here and use that here and here. Child. Okay, close. And so now this is return inner is equal to this. Okay. Now this is still working the way I expect. And I'm expecting it to work. So that's good. Okay. So now what we should be able to do is we should be able to like fuck that type up and do whatever the fuck we want with it. So what I want to do right now is I want this thing to get the array length bytes. We need to align forwards to inner type size. Like inner type alignment. Then consume array len bytes. And then instead of like parsing this now, I really literally just want this to be like the data itself or something. This is going to be very similar to the variant stuff we were doing in the happy hour segment, which this is maybe still, maybe not. So this guy, this is literally just like this. Now. Oh, which is bad because that means that all of the type detection we did was broken now. So we'll call this inner 2 just to make sure that anywhere where we were doing that it gets broken. And then can we do this like this? Okay. Oh, fuck. We didn't even use the name, so that doesn't even fix it. That's funny. Data. Okay. So this guy now, where we did this is, I think it's just TT. I think. Which is funny. No field name inners. This is now we're trying to just return data of undefined for now. Do you have your nvim config anywhere? No, I do not. I do not. Partially by design. Partially. But partially because I just don't want to like accidentally leak stuff. So I just don't throw out my dot files and I don't want to think about it, so I don't. Okay. So I guess this is like we probably want to like switch on the type, and we want to like get the alignment of that type, which we have somewhere. We just did this in the variant2 stuff. This. Whatever the fuck this is. I guess that isn't quite right, because this is based off of the tokenizer, which is not what we're doing. So weirdly, this is again unique code. So I guess we want to get the alignment of each of these guys. So can we just do like align of get dbus alignment, maybe we'll call it. And this will return a U-side or something. And this, okay. These guys are 4-byte aligned. Variants are 1-byte aligned, I think. I don't remember. We'll play it by ear, and then when shit breaks, we'll get mad. We won't think, and then we'll get mad. U32, I32 is covered. U64, F64, I64, these are all aid. And here we'll be like compile error, unknown alignment for type name of T. Perfect. Okay, so now down here we can just be like dr align forwards to the dbus alignment of TT, the child type of the array, and then we do toss all of this shit. And I think that should work. Unknown alignment for variant 2. Hello? It's right here, no? Oh, because this is KV. Oh, okay. So, we need to handle structs as well, which we haven't done here. So, here we need to be like, switch type info of T. If it's a struct, we are looking for specific markers, right? So, if has decal dbus array marker, on T, this is 4-byte aligned. Otherwise, it's 8-byte aligned, I think. It's like something like this. We're getting close. We're getting close. I don't know, man. Okay. Expected U32 on U size. Okay, fine. We can be a U32, motherfuckers. Okay, so now I guess we want to look at like what did we learn from the variant stuff? That we want to store the whole array up to the point that the array ends, I think. So we're looking at like dr reader buffer from 0 to the current seek position. And then I think that means we also want the start position in here. Okay. So I guess we want data start here. So we do like start is wherever the fuck we are on the buffer. So we got kind of like here. Oops, start. Yeah. Sure. Okay, so now what we want to do is we want to implement the part that does the lazy parsing, right? So before we were parsing up front, now we should be able to go like on a dbus array, we probably want, like, an iterator, which is going to do something. I don't fucking know what yet, though. So this guy's going to have, like, a next on him that returns a t, presumably, right? Right? And how's he going to do that? He's going to call parse body inner somewhere with t, right? That makes sense. I think that allocator and scratch are unused now, so I'm just going to throw in undefines and get mad later. Endianness we do need. So I'll throw that in here, fuck it. I'm not really convinced that I think that's where this should go, but it's fine. Okay, and then what the fuck are we parsing? We're parsing given some reader, right? So I guess here we're going to have our offset and the data. And I think when we construct this thing, we set the offset to the, like, start position. We set the data to the data. Right? And then in this guy, we probably make a reader. So we, like, make some dbus message reader, and we, like, initialize him such that we are at the offset. And the data, the reader, I guess, is a he's a fixed reader, so IO reader is a stood IO reader fixed. So he's wrapping the data that we have, and then we are I guess this gets set to the beginning of the buffer, and then we immediately toss this offset. We need to, like, keep this data matching the original data position-wise, because this guy, like, does a bunch of stuff based around alignment, so we need to make sure that the alignments match what they were in the packet when it came in. And then I assume that this guy wants our fucking reader. And there's a chance that that's it. There's a chance. There's a chance. So I don't know. Let's fucking see. So here, now we should have, like, iterator is parsed iter? Seems kind of reasonable. While iterator next, I mean, this guy's gotta sometimes give a fuck up, right? And then also at the end, we need to, like, adjust the offset. So I guess this is, like, I don't know, man. I guess we, like, have some return thing here. We probably check what our offset is now. So this is going to be, like, reader. Like, how far into the buffer are we now? Probably. This thing can fail, surely. And then probably in here, we're doing something like checking if the offs is the same as the data len. That doesn't seem crazy. I don't know, man. I think I want U32s everywhere, because I think we made that choice at some point somewhere. I don't fucking know, man. Okay. This guy's mad because he's like, yo, this thing is of type integer. True. Yeah, because this is a TT now for the child type. Holy fuck! Holy shit! Holy shit! Either it works or we didn't do it. One of the two. Holy shit, that's crazy. Um, dude, you love it when it just fucking works first time. Because I don't really even know what we did. I just was like typing and just like randomly ended up at a solution that's like kind of right. So I guess what we do is we just fucking remove allocators everywhere and just see what happens. Right, so 2 concrete now. Just fuck these motherfuckers. Get these out of here. Debus parse body inner. Fuck yo allocators. Bro. Fuck yo allocators. We don't need them. We don't need you. I don't want you anymore. You guys remember in what's it called? Toy Story? When Andy's like, I don't want you anymore. And it's like really, really fucking sad. I think about that all the time. I don't want you anymore. This is not a fucking, this is generate. Code generation, we have some like alloc shit that we just don't need anymore. Just never allocate, motherfucker. Never allocate. I don't want you anymore. Was that all of them? I'm actually really unsure. Needs allocation? Nope. Nothing needs allocation, bitch. No allocators. Fuck those. Fuck those. We don't even want them. Allocators? Who even asked for those, dude? Alec, get the fuck out of here. Buffer, get the fuck out of here. Oh my god, that's so fucking sick! That's actually huge. That was way easier than I thought it was gonna be. Way easier. So now, all because of this little guy, Mr. Dbus Array, who holds a chunk of a packet as well as, you know, where he belongs, where in the packet our array starts, we now just have like an iterator that acts like an array, does lazy parsing, and actually fucking works. It's fucking crazy. Fucking crazy, baby. And so it's like this, this makes it so that I think that we've like fully at this point removed our dependency on our standard library. It's only used in testing. So this can just kind of like get deleted and we can just throw it in like a big test section. Test. Boom. Boom. Wait. Can you not do imports only for tests? I thought you could, but you can't like nest tests like that, so maybe you can't. Oh well. Oh well. What you gonna do? What you gonna do? But I guess it should be clear if we come in here now and we have our why does this guy think he needs stud? I think he doesn't. I think this guy was also forwarding stud around 2 modules. Because he needed to pass the linear allocator around. Maybe? MPRIS? Yeah, stud's in here. Literally just for allocators. Yeah, so just kind of fuck that shit. I don't understand. Here it is. Delete that line. And then in build, anybody who's passing, you know, stud, fuck that shit. Dbus mod stud, fuck that shit. Generate can still use him. And so now if we go in here, oopsies. This is still in there, but only for testing. So I don't know how to like, I don't know how to enforce this here. Is there like is there a built-in? Can we check built-in test is test? Nice. Let's fucking go. Okay, so this does like solve a big problem here where I had like this like nasty tree. So it's like if I have like my app, right? And he depends on dbus, and then dbus depends on stud, and then we also depend on stud. This is like kind of gross because like you kind of need these to match if I remember correctly. At the very least, if they're in the interface, they need to match. And I think also if they're not in the interface, they need to match. Which meant that like when I imported this guy, I had to like manually inject my version of stud into him from here or something. And then like what if these like actually don't match and they have different code constraints and stuff? So there's probably a way to make that not suck, and there's some way to manage that problem. But we've just managed to dodge it completely. That's the best fix, is if your libraries don't use libraries, you can't have this problem. So, yeah, that's hype. Cool. There's probably more work to do here. A lot of more work to do. Because what were we trying to do today? We were trying to get to the point where we can use this library to write a service for our taskbar. But if you're watching on YouTube, this YouTube segment will probably end here. And we'll keep going on Twitch. So if you're watching on YouTube, thanks for watching. There's a Patreon, there's a Twitch, there's a YouTube member segment where you can see the rest of this stream. But you know what's going on there is typically not like big feature development or stuff that I feel like you need to watch to follow along. But if you want like more content that's like a little less structured, you can look there. But that's all the plugging we gotta do. YouTube, peace out. Twitch, let's keep going.